Hi guys, this is Stone Edge from BitBuild, and today I'm going to present the Retro Lite CM4, which is a collaboration project between myself and the DMCK5 that we worked on for over a year and a half. And yeah, I'm excited to show you guys and walk you through the features of the build. And we'll also do a quick teardown at the end of the video to show you sort of the internals and what it looks like. Now this is a prototype. Both of these are sort of, I suppose, prototypes in the sense that we do want to release some sort of kit version for people to build and have fun and make their own. However, there is a lot of obstacles to sort of overcome at the moment with the current global chip shortages happening. It makes it very hard to get your hands on a Compute Module 4 from Raspberry Pi. Also in combination with the custom PCBs, which make it quite difficult to get hold of all those parts. So this is the Retro Lite CM4. It's running a Compute Module 4 inside with 5 custom PCBs. So I'm quite excited to show you around the system, and then we'll do a quick teardown. So let's get started. As you can see on screen, this is the Retro Lite CM4, and this is the front of the case. And as you can probably tell, I've got a real switch here to sort of show you guys what a real switch looks like, and then our model here. So I don't know if you guys can see that, but it's a pretty close match to the Switch Lite is what we were sort of going for, with obviously a couple of changes. Now it's not 100% match to the shell. I have one of those slim Switch Lite cases that unfortunately it just doesn't close over the top of this design. So there is some slight differences, but overall we tried our best to match that. And I think my project partner did a fantastic job. It's very comfortable to hold and play. So let's focus on the front of the design quickly, and then we'll do a quick teardown. So it's running a 5-inch IPS screen, 800 by 480 pixels. For resolution. Now, I know that a lot of modern screens, have 1920 by 1080 or a much higher resolution. And obviously the Switch Lite screen is a 720p display, 1280 by 720 with a 5.5-inch screen. And I think we would like to integrate that into our product, but I think the 5-inch screen does the job for all retro gaming. Obviously for game streaming, I think the higher the resolution, the better. But for your older titles, like as you can see here, Super Nintendo, Dreamcast, this screen does a fantastic job. I don't think that it really requires anything more higher pixels than that. Obviously, I think a bigger screen would be nice, but this is a lot cheaper. And yeah, I think we just went with this option at the time. Obviously, integrating a 5.5-inch screen is tough because generally I haven't seen any HDMI-driven screens that are that size. This one here is driven by HDMI. So onto the control system, it's very similar to the Switch Lite. You've got a start and a select button here with a D-pad here, which is quite clicky. But underneath here we have some silicon membranes, so it's relatively a very good D-pad actually. You can push down in the middle here, but you can see that even if I push down in the middle, there's really no movement on the screen at all. So it's got a very well designed pivot in here, and you can pull off things like Hadouken, sort of Hadouken moves in Street Fighter 2. It's a very well designed D-pad. I'm really happy with it. So that's a D-pad, and then you've got your A, B, X, Y in the Nintendo layout, and then 2 switch sticks, which is quite uncommon actually on a Raspberry Pi handheld. Most of them only have 1 analog stick, either because they've sort of replicated the Game Boy Advance form factor, or they've gone for more of a DMG style. This one has 2 fully compatible analog sticks, which work just fine. So that's the front, and then onto the top, we've got a stacked shoulder button layout here, which I really like. A couple of changes probably will have to be made to these for manufacturability purposes, but you can see here it's very nice to hold exactly like a Switch Lite, and your fingers rest right on these triggers here. And then you've got your L and R buttons as well. So stacked shoulder buttons, which works really well for PSP games, Dreamcast. Now they're not analog, obviously, just similar to the Switch Lite, just a 1 press down. However, they're quite comfortable, and yeah, I'm very happy with those. On the top, we've got a heatsink here with a really custom designed heatsink, which is excellent. Keeps the device nice and cool with some thermal paste. 2 screws to hold the top and bottom together. A headphone jack here, which automatically switches to the internal external audio. And then we've got the 2 volume buttons here, plus and minus. And actually adjusting these here will bring up a on-screen display up the top left there. And we adjusted in 10 steps of volume. The Switch Lite has 15 steps, but we decided 10 was enough. And as you can see there, I've got some background music playing in the background. That's just courtesy of a script I'll leave in the description. So that's that, and then we've got a power button. This one here will safely shut down the system. Holding it for 3 seconds will shut it down, and pushing it again for 1 second will turn it back on. And that's done with an internal microcontroller, AT tiny microcontroller, which does the job. All right, moving on to the back, there's not a huge amount to see here. We have stacked shoulder buttons, and now this is quite a controversial thing, particularly for manufacturing. I know a lot of people have suggested that we'll be sued for this logo, and indeed you'd be correct. This is something that we only really made these designs for ourselves, so it didn't really matter what we put on these, to be honest, for a prototype anyway. So I quite like it, and it shows that we were inspired by Nintendo's work, and I think it looks all right. But obviously, if we're going to sell these to other people, this is obviously a big no-no, given legal IP concerns. So that would be removed and replaced with their own custom logo, and then just the Retro Lite CM4 engraved in the bottom there. Onto the top, I suppose the bottom now, we've got a USB-C port here for charging. Unfortunately not OTG compatible, so only 15 volt charging, 15 volt 2 amp charger, 2.6 amp charger, which is the Switch Lite charger, works just fine and charges over USB PD. So we get roughly, it's roughly 2-hour charge time to charge up the batteries. And then a HDMI mini port here, mini HDMI. For video out and audio out to connect to a TV. Would have been nice to integrate it all into this one port, and I know that is possible, and perhaps later down the line we will look into that. However, for now, just an external mini HDMI port, which works just fine. I think I use it quite often. And then your SD card here. Unfortunately, on this build, the SD card is sort of hidden. And again, I think it would have been nice to have a push-pull slot here to push that and then remove the SD card, but for the time being, it's sort of hidden away and you have to open it up to get the card out. Just because it holds the operating system, and I sort of didn't want to knock the operating system, accidentally bump it and sort of take that card out. So it's sort of just recessed in there. You can't take it out without getting some sort of tweezers in there and pulling it out. And then 2 speakers here. 2 front bottom firing speakers, which get really loud. I'm quite happy with those. And yeah, that's pretty much it for the hardware. So there's a couple of other features that I'll show you quickly here. So courtesy of my good friend's hard work, holding select and down on the D-pad here will, as you can see, allow you to adjust the brightness of the display. That's also done in 10 steps, and you get a little heads-up display at the top left there. So it's quite a nice little feature to have. In terms of other features, you've probably noticed here, there's a little battery indicator that also operates in 10 images. So 0 to 100% in 10 steps. And you've also got the SOC percentage there. We used a fuel gauge, a Max 17055 from Maxim Integrated. And that was just sort of the fuel gauge that's well used in the community I'm a part of, and they recommend it, and it works extremely well on the Pi. It was relatively easy to set up. We had some issues, but relatively for a fuel gauge, I thought it was quite simple, and it does the job for high load current draw. And speaking of which, by holding select and R3 down, you bring up our controller menu. Now this is all custom programmed again, so really happy with how it is. But the first it's broken up into 4 sections at the moment. The first section is battery information, and this will show you the current SOC, voltage of the battery, instantaneous current. So at the moment when I click the button, we were drawing about 1 amp from the battery. And we've got a 4,000 milliamp hour design capacity battery in there, with a remaining capacity of about 1.1 amp hours. So that gives us another 1 hour of gameplay. Roughly you get about 4 hours out of the battery, so it's quite good, I think for what it is. And then yeah, charger disconnected, so when you plug that in, everything will change. You can also calibrate the controller, which I won't show you guys that, but by hitting that you can calibrate the joysticks to the proper ranges. And we also have an on-screen keyboard here as well, so you can come around and click exactly, if you want to, you know, for example, you don't have an SSH computer or you want to put in a Wi-Fi password, you can easily pull this open. Also, it really does work well for standalone emulators as well. If you need to perhaps push escape to sort of program up your controller and map it, you can do it with this. You can SSH, you can go to terminal and type in whatever commands you need to do. So I think this is really handy to have. And then finally, the settings menu, you can adjust things like the shutdown voltage. So I'll set it to 3.1 volts, and then the battery capacity, so 4 amp hours, and you can adjust the fan start temperature. So you can see here that I've got it down to about 35 and the fan starts spinning. And then if we want to boost it up to whatever temperature to start the fan, you can adjust that. And there's also a little bit of a fan curve going on, so that works well. And you can also adjust the external display. Automatically will switch to the external screen when you plug HDMI in, so no problem. But if you want to sort of force that, you can also do it through the settings menu. And then the OSD color, so that's the battery indication up the top there, and also the images, you can change them to be white or black. So that's pretty much the Retro Lite CM4. Let's I'll just save and reboot, and then I'll pull it apart. I think you guys might be interested in seeing a teardown of what it looks like. So I'll just turn it off quickly, and then we'll open it up. It's quite simple to get to, so shouldn't take too long to sort of open it up. Now I forced off the operating system, which is something you do not want to do. So that was bad practice, but I want to tear this down. So first things first is to take off the 4 screws, so 2 up the top. And I'll just quickly do this now. I won't skip the video just because I can't be bothered editing it afterwards because I'm lazy. So we'll take out, these are M2 by 2 screws, which are quite difficult to find actually, but they do the job. And they just really seal it all together. You sort of do, in my opinion, I think you do need these screws to seal it. And I think they're obviously not discreet, but I think they're not like standing out too much. All right, and then finally there's 4 screws here. So let me remove these quickly, and I'll just turn this around so that you guys can see exactly how it looks. So they're just hex screws here, quite simple to take apart. And hopefully I'm capturing everything here on camera. I'm not 100% sure if you guys can see absolutely everything, but hopefully you can. So it just takes a little bit of prying. It is very thin, about 13 millimeters, same as the Switch Lite. So yeah, it's a little bit difficult to get apart, but you can see here, I'll just pop it off the back. Okay, the fan has come off there, which is not great. I'll just move that over here, pop that back. All right, I'll just move the screws over here. Sorry about this. All right, so we're looking at the internals now of the Retro Lite CM4. As you can see, it's a relatively neat build. I think it's quite easy for people to put together, hopefully, when we do release some sort of kit. And as you can see here, I've got another prototype PCB, so it does take the Compute Module 4 here, and that is the main PCB sort of that connects everything together. You can see I've got the external HDMI here and USB-C, but I'll show you on this board here. So you've got a custom Retro Lite battery here, 4,000 milliamp hours, with a custom skin. Now, again, I don't want to get into details about the IP stuff, but this will be changed to make sure we're in compliance there. But we have 2 circuit boards here for the controller PCB that is using an Atmega 32U4 IC, which has buttons. Each pin is corresponding to a button on the console, and that's powered on 5 volts through this FFC cable here. Now we have the switch stick analog connectors here, which are 0.5 millimeter pitch in diameter. And then we've got 2 speaker ports here, and unfortunately these are not closed ports. I'm thinking of designing or wrapping these up in some sort of cover to sort of increase the low frequency response of the speakers, just because there's nothing really sort of enclosing them at the moment. So they do work well, but I think they would sound a lot better with some enclosed casing, just like the Switch Lite does. But you can see there are 2 stereo speakers here, and they're actually soldered directly to the PCB, which is not great. It would have been nice to have proper connectors, because I really don't want to have to. I feel like if we make a kit for people, I think people who don't have any soldering experience, it sort of adds an extra barrier to the console, unfortunately. So you'll have to solder 2 speakers here, and also you'll have to solder 4 wires here for the daughter PCB. So you've got your buttons here, which are the shoulder buttons, which are sort of hinge design. So no spring, but a hinge, and they work pretty well. You can pretty much actuate them at all surface area of the button. And then, as you can see here, just a daughter PCB with some double-sided tape on the back. And then we've got a power and volume, as I just said before, and the headphone jack. This is the main CM4 here. We're running the 2 gigabyte. This is 2 gigabyte RAM, 2 gigabytes of RAM with the Wi-Fi on board. So and Bluetooth as well inbuilt. Now, this is a metal case, so I will not lie and say the Bluetooth performance is great, even with an antenna, which you can see here. I've salvaged this antenna from a Nintendo Wii, actually. But unfortunately, the range of the Bluetooth is relatively poor. Unfortunately, that's just the sort of nature of dealing with an aluminium housing. It still does work, and Wi-Fi is relatively good, but Bluetooth is still, I think, not so great with this antenna. But I haven't tried many other antennas. However, this antenna, it's not fantastic. So that's probably one downside of the metal case, but it is very high quality, and it feels excellent to hold. So let's just quickly run you through some of the main circuit board. Here's the SD card. Here's the fan connector, the battery connector here, HDMI port, USB-C charging port. Up here we've got the audio circuitry and the backlight circuitry here to drive the screen backlight. And over here is the AT-Tiny, which is controlling the battery management down here via I2C. And then we also have that shutting down safely the system, and also managing the low voltage shutdown from the Pi, communicating directly to the AT-Tiny there. Here's the encoder chip for HDMI. Now, again, I think we wanted to use I2S audio on this CM4, so we went with the HDMI video for internal video. There's a couple of options with the CM4, one of them being direct parallel interface, so DPI, driving the screen directly through the GPIOs. However, that leaves you with very minimal GPIO uses. Also can't use I2S, so we opted against using that and went for this solution. So HDMI video directly drives both this external port and also the internal screen via this encoder chip here. Now it's a little bit expensive, unfortunately, the encoder chip, and it's pretty easy to implement. However, routing it was not that fun, and it does take up a relatively large footprint size. So I think eventually I will integrate perhaps a MIPI HDMI bridge IC or some other solution apart from this. We've got another FFC here that connects there's all the controls here. to the main board, which then connects here and then goes over to the IC to communicate. And you can see here I've got some silicon rubber membranes here, which are just custom made, and they really add a nice little soft touch to the button here, which is just very clicky, but as soon as you add that little rubber membrane back on there, it gives it a really nice soft tactile feel. So that was really smart thinking from my project partner, and they really add a nice feel to all the buttons. So there's these rubber membranes on all the buttons, which is really good. And here's the fan. This is a 30 by 30 by 4 millimeter fan. It's not the best fan, but when you sort of have very little room to work with, unfortunately, in the design, we sort of had to opt for this fan. And I'd like to thank Kite for suggesting, from Pseudomod forums, for suggesting this fan. It's a really good fan, and it's better than the one I used previously. All right, now I won't bore you guys anything more with the internals of the Retro Lite CM4. That is pretty much it. That's all I have to say, pretty much. Let's put it back together quickly, and I'll show you how easy it is to sort of get back into one piece. Hopefully I don't stuff anything up here. However, as you can see, it's a little tight, so you sort of have to snap it together carefully. But that's pretty much it. We'll screw it back together. So just quickly to answer people's questions, I think a lot of people are asking when can we buy one of these, and unfortunately I don't have an estimated time of arrival for kits right now. It's a lot of work to build a kit like this, and there's a lot of optimizations that we sort of want to do, a lot of more testing, but hopefully by the middle of the year perhaps. I don't want to make any promises, but we sort of would like to do this and get them into people's hands. But we both do have full-time jobs, and yeah, it's not exactly easy to source all the parts right now, as everyone knows. So yeah, that is the goal though. Rest assured that yeah, we do want to make a kit, and we will probably absolutely open source everything as well, so people can build their own if they want to. The software is already on my GitHub, which we're constantly updating. So if people want to check that out, by all means, please do. But yeah, that's the sort of the status right now of the handheld. So I've just got 2 more screws to put in. And these screws are really small. I actually lost one, unfortunately, so I sort of, yeah, that wasn't great. But I've got a little long